No, afternoon. Just checking if you're hearing me.
Yes, sir, we can hear you.
Okay. Using a different set of headphone. So let's see if I'm going to steal this headphone. All right, just waiting on some more people. When we reach 10. No, so just occurred to me. Somebody can resend the link in the group. I haven't had a phone for the whole week, so just get a phone, put it charging.
But, sir, isn't the link in the description?
Yeah.
Yeah, so they would just have to just simply look at, so they have access to the link then, because they would it would just be in the description.
All right. So but do it as a test space. Just send the link
All
in the
right.
group. And let me see if
All
the
right.
numbers.
Okay.
Yeah, that didn't work. Well, just have to begin. Who's going to do the recording? All right, let's begin. So I want to talk about programming the analog input in the PLC. Right. You know what? Let me record. Sorry, one second. All right. So last time we were saying that when you have the PLC, the parts that we have here with the 0, 1 and 0, 2, these are digital outputs, meaning that you can turn on and off. And over on this side here, we have our inputs and binary inputs so that we connect our sensor on and off and those things, sensors to our input side over this side here. Now this part of the PLC, like I said, the political part is our analog input. So we connect our whatever sensor it is that has either 4 to 20 milliamp signal, it's a 1 to 5 volt signal, 0 to 10 volt, or minus 10 to 10 volts. The input has to be one of these. So whatever sensor we are using, it is going to be required of us to be using one of these modes, whether be 4 to 20, 1 to 5, 0 to 10, or negative 10 to 10 volts to connect to our analog inputs. And we say that up here, the part that says A to D, analog to digital, this is input 1, input 2, input 3, and input 4. The first two, 201, 202, 203, 204, and these are outputs here. So continuing in the sequence. So that will be our analog input and output. So the next part that we need to talk about when we're doing analog output is that we have to open this section here. That that you see that says peripheral. You have to open this section here, and then what you will see, these sets of the set of switches, very small switches that are in red, that you have to say whether it is voltage or current for each of the following inputs. And you notice that it says on is a voltage input, and off is a voltage input, and on is if you have a current input. So the four inputs that you have and the outputs, we say that the first two of these inputs here, you would have to decide for each of them whether it's going to be voltage or current that you are going to be attaching your sensor. So for example, if you're attaching a thermocouple, then you know that it is it's either 1 to 5, it's as a voltage 1 to 5 volts or 0 to 10 volts that you would be. If you're attaching a thermistor, then it might be a current signal that you are using, a 4 to 20 milliamp current signal that you are using. All right. So just to reiterate the point that when we are programming the analog input, first thing that we have to do, these parts up here are our attachments. Then we have to open the peripheral. This here peripheral, and then we have to adjust the switches based on what we are going to be doing, whether it be a current or a voltage. All right. So the next thing that we have to do is go to settings. So let me just bring up that. What is it that you are seeing now? Is it the document or you seeing the PLC?
I am seeing the PLC setup. Is that you're referring to?
Oh, you see the document. All right.
Yeah.
I was actually opening the PLC. So the setting up of the PLC. So here is the thing now. This is the physical. So this is the physical input that I keep on assuming that you're seeing the mouse.
Yeah, we can see it now.
So this is the physical input, and we're saying that you have to open the peripheral, and when you open the peripheral, you have to say for each of the peripherals whether you're going to have whether it's a current or a voltage input. So you have to set the switches here for a current or a voltage input. Now, here, the other thing that you'd have to do is go to the PLC and go to settings. And then when you go to settings, then you have to go to the A to D converter. So let me just go to that. So here we are in PLC. We have to go to settings. We have to go across, built-in A to D converter. Now, so each of these, if we're going to use, let's say we're going to use first thing, let me do the first thing, resolution. Whether it be 6,000 or 12,000, the resolution. I'll talk about a calculation, but remember now, resolution has to do it. So let us say that I have 0 and 1. And then, so when it is on 6,000, between 0 and 1, for example, or well, let me use, so between minus 10 and 10 volts, you can either choose to have 6,000 spaces, or as is here, you can choose to have a greater resolution. So the spacing, the voltage, machine can detect greater well, I want to say number decimal places, but the thing is more finely divided and the machine can detect a smaller change in the voltage. So you'd have to decide whether you want 6,000 or 12,000. What is the resolution that you are using, depending on the application that you have. So as I've been saying, so it's either minus 10 to 10, 0 to 10, 1 to 5. I don't know about 0 to 5 and 0 to 20, but I've seen equipment where it has that on it. So I presume that you can use 0 to 20 and 0 to 5, but let me just reiterate that the standards are negative 10 to 10, 0 to 10,
0 to 10,
1 to 5, and 4 to 20. Those are the standards. When you have a sensor, that's the instrumentation standard. Yes, you have sensors that work with 0 to 20 milliamps, and you have 0 to 5 volts sensors. And so you pick whichever one you are going to use. So let us say the first one is 4 to 20 milliamps. So you decide which each of the channels, 0, 1, 2, 3, and 4. Sorry, 0, 1, 2, and 3. These 4 channels that you have that you can use for the analog to digital. And then you have 2 output channels that you can use. And the range of the output, you would have to decide that as well. So those are some of the physical things and the things that you have to set up in the software before you actually begin to write a program. All right, so you have to set up all of those things and look at the equipment that you're going to be using and sort it out before you begin to attempt to write a program. Okay? I don't know if what I've been saying making any sense, because the computer is looking back at me and I'm not sure if what computer not saying anything. So I don't know if you have any questions or you understand what I've been saying. So reiterate, you have to go to settings and decide what is the range that you're going to use for each of the channels, and then determine what you're going to do from there. So let's just go back before we actually write a program. So you have to set up your channel. Okay, so this is what we're talking about. So the first set of pins, like we said, is common voltage, so everything has to be connected to any one of these. And the connection is that the first pin is positive and the next one is negative. So you have to bear that in mind in each of the pairs. So as you can see, this is the method of connection for the analog input. That you can see that the one is positive, one is negative. This person is using analog input channel 2. So well, as you will see, the little bit further down. So that is in the program, where he's connecting this to. It's CIO 202 when you're writing a program. But we're going to get to writing a program, but we just have to get through the mechanics. Okay, so analog input 2, as I was saying. So these are the analog inputs that they have. So and I was telling you that I was saying that the output is 0, 4, and 0, 5. It's 0, 10, and 11. I was thinking about another machine. So when you're writing a program, you're going to you don't have to put the CIO, as you will see, but you have to put the 200 and 201 and so forth. But if you put the CIO, it will be accepted. All right. I'm going to send this document to the group as well. I keep on promising to send documents and I don't send them. But I was without the phone, so I was without WhatsApp for a little while. More than a week. Okay, so if you observe here, this is an output. If you look at this program that is here, this is the address of an output, and this symbol here is move. So you move whatever value you have to the output. So that we're going to be using that in a little while, because we want to do a little exercise. But like I said, getting through the fundamentals of it first. All right. So all right. So what I want to do this afternoon is go back to our little situation that we had last. Let me see if we can get that diagram.
Wait, question, sirs. I've not finished watching the first 2 classes that I had missed because I was one of the persons who wasn't able to join the class until I think it was 2 weeks ago. So I wasn't at the first 2 classes. Is there a place where we're supposed to download the programming software to when we're going to start writing the code?
We're saying that you should download it to your laptop. So CX1, and the first, you were to download it to your WhatsApp, to your computer or your laptop, so that you can practice writing the code on it.
Okay, so just ask somebody for where for the sites that I would have to download it from.
Yeah, if you type in CX1 home run, it will come up and you will see the site where you can download the program. The CX1.
CX1.
Somebody who downloaded recently help me out now.
Okay. Yeah. Okay, I'm seeing a lot of
weird. Watch you just watch a YouTube video and download it.
Yeah, so is it just called CX1? Because I'm getting a lot of results for CX1.
It name CX programmer version 9.7 CX1.
CX programmer 9 what?
What version 9. I think I the latest version, but at the end you gotta see CX1 at the end. You not gonna see CX1 when the name start. You gotta see CX programmer.
Okay, no problem. Thanks.
All right. So let me go back to an example of programming a furnace, for example. So let me just find a better picture rather than me try to draw it, because my drawing is now, I don't know, and get late. I'm just going to use see if this works. All right. So we have a furnace.
That's why I asked them, sir.
So it has a heater and it has a temperature sensor, and both of these are connected to a PLC. So this is connected to the analog input. Analog input, let us say that's the first analog input, so it's 201. And the heater, let us say that it is connected to a binary output. So what we have is an on-off control. So let us say that we are going to have on-off control of the system. And what we mean by on-off control is that when it reaches a certain temperature, so let us say that the temperature that we are going to is 500 degrees Celsius. And then so that is the value at which we want to keep the temperature at. Now, the problem, first of all, we have to just deal with something before we write the program. If we have 500 degrees Celsius, and that is where we want to keep we have this thing. If we write the program to say that when you reach 500, turn it off, and when you below 500, turn it on, then we end up with this thing called chattering.
So you need to give so you need to give some leeway for like maybe if it goes up by one degree and things like that.
I didn't hear you.
I was saying, so you give some leeway in terms of even if it's not exactly 500, yeah, yeah, you can make it go a little bit above our tolerance. Have a percentage tolerance. So, say for example, you would have a tolerance of maybe 5 degrees Celsius. Is that referring to, sir? So, if it goes five below or five above, it's still usable. What is something?
Yeah, I just realized that I was kicked off.
Oh,
All right. All right. I don't know where the kicking off stopped. Where the kicking off started, sorry. So let me start back from beginning. So we have a system that we are describing here, and it's going to
the kicking off stopped when it started when we were talking about the 500, and then you're gonna explain about the chattering, and then I was gonna ask a question pertaining to like, are you gonna explain about like tolerance in terms of like if it goes 1 or 2 degrees above or below, it's still usable. It's not just gonna automatically lock off.
right. That's what we are going to talk about, which is the word that we are going to use is a dead band. So to avoid chattering means that it's going to go 500, 499, turn off, turn on, and so forth. To avoid that, because like I said, that damages the equipment, then we are going to have what is called a dead band. All right, but before the control symbol, so you have your controller, which is your PLC, which if you're using on-off control, the symbol for on-off control is as inside the controller. And you have your plant, and in this case, it is your heating system. And you have your feedback. And your output. Now, if your controller has what is called a dead band, now what is a dead band? What, instead of saying at 500, let us say that we say that our lower limit is 490 when we want the system to turn on, and our upper limit is 510 degrees when we want the system to turn off. So what is going to happen now is that the temperature is going to the on and off time, the time between on and off is not going to be, you're not going to have chattering, but it's going to be more space. And the greater the spacing that you want, then you have to increase the dead band. So the dead band is the region in which you take no action. So let me just write that somewhere here. All right. So if we have a dead band, then how we indicate it in control terminology is like that. If we're drawing. So if we're having a dead band, then we just indicate that is how the controller is. So our system that we want to have here. Sorry. I'm trying to get this thing working in a way that these things decide to stop work. I'm going to go and get another mouse. All right, so we want to write the program. And so there's one other thing that we want to talk, we need to talk about, but I'm going to talk about it after we write the program. So let us agree on some things now for us to write this program. So I don't know what is going on here. Okay, so we have this program that we are going to write. So the heater is on off. The sensor is an analog input, and let us assume that it is a thermocouple. And our analog input is 201, so this is a thermocouple. And let us assume that it is 0 to 10 volts. So I'm going to write the program initially. We say that our deadband is, the upper level is 510 and the lower level is 490. So this is where we turn on, and this is where we turn the heating element off. So we're not, at this point, we're not concerned with the other things inside there, that inlet valve and high level. We talked about those before, but on the outlet valve, we're just concerned with writing the piece of the program that controls the temperature. All right. So we other things that can happen inside there, the mixing at the high level and the low level and the letting in and letting out. We can consider that as another sub-program that we can talk about. And we can talk about this sub-programs, but we are just concerned with writing the controller for the temperature. All right, so to write the program, all you have to do is sit down and think about, if you were the controller, means that you had your hand on the switch and you had a thermometer in your hand to take the temperature. What is it that you would do? And bear in mind, we're not talking about the rest of the program, we're just talking about this segment where we can control it. So what is the first thing that you would do? So tell me, what's the first thing that you would do if you had a thermometer? So if this was you, in one hand you had your thermometer, and the next hand you had the start and stop switch. For the heater. All right, so what's the first thing that you would do?
So after putting the thermometer in the container.
All right, so first, whoa, stop. So what we are going to say is that you're going to put the thermometer in the container. Yeah, and all right, proceed. You put the thermometer in the container.
Okay. Are we to assume that the start and stop for the heater is already on the container already, or do we still have to?
Yeah, man.
Okay. So so if the thermometer reads below 490,
all right,
then
All right, so we're going to stop it. So the first thing you're going to do is say you're going to read the thermometer. So you're going to move whatever is on 2 or 1 into data memory. So
Right.
you're going to move the temperature, and it's a furnace, so we do it every minute. We take the test temperature every minute. So every minute I would move the temperature. All right. So what is the next thing that you do after you read it? You say read the temperature.
So you now do a logical operation where if the reading that was stored if the reading that was moved um, is above or below a certain range, in the example I gave, if it's below 490, so if the moved value is below 490 degrees, then
All right.
we send a signal to the heater to start.
All right. So we're going to compare
Right.
whatever is in my data memory. So the value that in the data memory, for the time being, I'm going to write 490 degrees. So I'm going to compare it with 490. We're going to talk about this 490 in a little bit. And if talked last week about the switches, so we are going to say that if it is less than or equal to 490, you want to turn on the heater.
Right.
What I'm going to do is turn on an internal bit. This is called an internal bit. So an internal bit is a memory location in the processor that stores a particular value, whether high or low. So if it is less than or equal to, we turn on this internal bit, 200. What about if it is higher? Well, the same thing. So we're going to compare in the same minute. We're going to compare D0 with 510. And if it is higher,
Do it. Use another internal bit.
so we're going to call this 200.01. So this is another internal bit. And we want to know if it is greater than or equal to. So this flag here, when we make the comparison, if it's greater than or equal to the temperature, then the flag is going to be set high, it's going to close, and then when it closes, it's going to close and turn on the bit. Okay. So every minute we move the temperature into D0. This is below 490, we're going to turn on the one internal bit. If it is above 510, we're going to turn on another internal bit. And then now, we are going to so now let us assume that the heater coil is 100. So that's our heater coil. And let us assume that or regular start switch for the system to turn on the system is 000.00. So we are going to latch our heater coil here. So that's 100.00. Now, we turn it on. This 200.01 is to turn the heater off. So this here would be our 200.01. And our 200.00 would be the one that will turn it on. So let's see if I get a better mouse so I can minimize this thing because the mouse is not working with me at all. Right? But this is the program. So now, when I press the start switch, it turns on the heater coil and it's going to heat up until, so this, when you press the start switch, it's going to turn on the heater coil. It's going to heat up until it is above the 510 degrees, or at or above the 510 degrees. Just to remind you that there are two flags. You can have strictly greater than, or you can have greater than or equal to. So when it reaches 200, it's going to turn off, and when it drops to 490, this 200 is going to close and turn on back the heater. So that is how we would do on-off control for our heater. Give me a second, let's see if we can find another mouse. All right. All right. All right. So this here is a program fragment. Right, like I said, the other issues that you'd have with inlet valve, and that would be another piece of the program, but this is just a piece that would be controlling the temperature. All right, so now let me turn to the 490 and the 510 degrees, because that would be the value that we put in our controller. So what would we how would we would have to do a little set of calculations. So let us just discuss the calculations that you would do to the control. All right, so let us assume that is a thermocouple. And so the temperature range that you want to measure, you would have to do some signal conditioning. So let us say that it goes from 30 degrees. So that is your 0 to 1,000 degrees. That is your 10 volts. So this is your 0 and 10. What you have to work out now, or what has to work out? So let us work out what voltage that corresponds to, and then we would have to work out what value we put into the program to represent the 500 degrees. Well, so we would use a straightforward. So 30 is 0, 1,000 is 10. So let's start with 490. What does that correspond to? So we would use interpolation, linear interpolation. So what we would use is the gradient. So x minus 0, y2 minus y1 over 490 minus 30. This is x2 minus x1. Supposed to be equal to the same gradient. 10 minus 0 over 1,000 minus 30. So that is x over 460 is equal to 10 over 970. So therefore my x will be equal to 10 over 970 times 460. Here is my calculator. If anybody have a calculator and work out at that time, please. Oh. So 10 divided by 970 times 460. I get, my mouse has disappeared, 4.74 volts. All right. So we know that 4.74 volts. So 0 is a hexadecimal number that we put in our PLC. So the hexadecimal number goes from 0, 0, 0 to FF, 0, 0 being the lowest and FF being the highest. So our 0 volts correspond to 0, 0, and our 10 volts corresponds to FF. So where does 4.74 fall in that? So we're calling that X. So what is the base 10 for FF? Anybody remember?
It would be 16 squared. Wait. Hexadecimal. It would be no. 16 plus 1. So, wouldn't it be 17, sir? Wait. Sorry, no? No. Wait, no. No. 16 squared. Sorry,
16
plus 16.
Subtract 1. 16 squared
Yes,
minus
sir.
1.
Yeah. Yes, sir.
Alright. So that corresponds to 255. So let's work out again. We're going to use the same principle again. So x minus 0, or the 0, 0 represents 0. So x minus 0 over 4.74 minus 0 is equal to ff, which is 255, minus 0 over 10 minus 0. So x is going to be equal to 2, we have so much 0, yeah, right. 255 over 10 times 4.74. So 255 over 10 times 4.74.
120.
How much?
20.87.
120.87,
0.87.
which is 121. Now we have to convert that 121 to a hexadecimal number. So if you have a calculator that does it, then fine. I have the $700 Janus knockoff from China. So Casio knockoff. So I have to do it by hand. Anybody remember how you do it by hand? $16 into 121. That gives 7 plus what is the remainder? 16 times 7. If you have a calculator, it will be easy. The remainder is 9. So that would the hexadecimal value. The electrical engineer would be 7, 9. So it would be 7, 9. Alright, so let's do the same thing for, so what we would have in our program. So we'll go back up and modify our program. So what
Yes,
we
sir.
have, huh?
You're saying that 121 would be equivalent to 79 in hexadecimal?
Yeah. So
Alright.
we would write 7, 9 up here. Sorry, we're trying to get this thing to. But there's only one way it going. I don't understand. Anyway, why did I about this and put 7, 9? And the same thing now we have to do for 510. So we have to go back through the same process. So 510, so 30 is 0. 510 is x. 1,000 is 10 volts. So x minus 0 over 510 minus 30 is equal to 10 minus 0 over 1,000 minus 30. So x is equal to 10 over 970 times 510 minus 30 is what? 490.
Wouldn't it be 480?
480, yeah. And then that value would be 10 divided by 970 times 480, so 4.95. And again, we are saying that 0, 0, FF is the highest, 0 and 10 volts, 4.95 corresponds to X. So X minus 0 over 4.95 minus 0 is equal to FF is 255. 255 minus 0 over 10 minus 0. So that would make my X be equal to 255 over 10 times 4.95. What is that equal to?
I get 126.2, basically.
So 126. So convert that to hexadecimal. Then we convert
I get 7E.
7E. Okay. So for the Ginos people, or the people with the calculator that can do that, 7. And then the remainder that you get is 126 minus 112, and that's 14. Now remember, say it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So 14 would correspond to E. So it's 7 plus E, so that would be 7E. So like I said, if you have a calculator that just does the conversion for you, better. So in here now, instead of 510, we would not have 510, we would have 7E. Because the processor would store all values in hexadecimal. It wouldn't store it in degrees. So that would be our program. And those would be the calculations that we would be required to to do. So any question? So what if we were to require to create a stack? Which is keep a log of the temperature data. How do we modify the program that we have here if we want to create a stack? Anybody remember? All right. So if we go back at it again.
Would it be the direct addressing?
All right. So we would use indirect addressing. So because what would happen now? Remember now, this up here that we have, that is direct addressing, you know. This that we did up here, that is direct addressing. Because we put in the value into the memory. And we're saying where in the memory that we put in it. So move the data into D0 is direct addressing.
Right.
Right. So now we don't want to keep the data because every minute when we move whatever is on the analog input into the memory, data memory, then what is in the memory already is already overwritten. All right. So if we want to create a stack now, then we have to create an area where we store the data. So we would do the same thing every minute. Move the data what is on 210. Remember I said the CIO can be left out into, instead of now D0, we put at D0. And then we would go to D0 in the memory and fill in a number in there.
Excuse me, sir. You said we put at or the number sign?
Number sign.
Okay.
All right. And we'll go to D0 and fill a number in there. So let us say, well, if we're doing every minute, then we wouldn't put 40 in there. I'm just putting 40 because every minute, but at the end of 40 minutes, we're going to be in a problem. But let us say we put 6,000 in there. So what is going to happen is that it's going to go and find 6,000 and store the temperature there. And then what we are going to do after that is increment D0.
So one thing I know is
So we're going to increment D0. So that means we're going to add 1 to D0. So we're going to have 6001. And then we're going to do the same thing that we have been doing. Compare. So we're going to compare D0. What is not the when you go to D0, well, this is the last thing that you would want to because it's going to say increment D0. So we shouldn't put that here. Sorry, this shouldn't be here. This should be the last thing in the program. We increment at the end, not at the beginning. Alright, so we're going to compare that D0 with what was it, number 79? And then if it is less than or equal to, we would, and so forth and so on. And then the last thing that we would do, we would put in the increment.
Sir, it's going to be less than or equal to what? What we're comparing this 79 to?
Whatever is at whatever D0 is. So let us say that D0 is 78. When we go to the 6000, it is the number sign, I keep on saying the number sign, 6000, in that the temperature that is going to be stored there is going to be converted to hexadecimal value. So 78 means 480 degrees. So this 480 degrees Celsius and this 490 degrees Celsius is going to be compared.
Okay, I get it now.
And then when it is compared, yes. When it is compared, if it is less than, then you turn on. It's going to turn on 200. Alright. So that is what the comparison is going to do. And then at the end of that sequence, we're going to compare to the increment D0. That's when we're going to increment D0. And then proceed. So if we wanted to create a stack, which is, like I said, a sequence of memory, then we'll just use indirect addressing. Yeah, we're gonna stop at the back. All right. So indirect addressing, we would use R, the other addressing mode, because if we had used at D0, it would create the same effect. All right. So if we use indirect or index addressing, we would have created the same effect. All we would have to do at the end of that is increment D0. The thing here keep on disappearing. Everybody hearing me?
Yes, we can see you here, sir.
Okay. All right. So if we are to write the program fragment, then that is what we would be required to do. All right. So we're in the position to post your first assignment. So we're going to post the first assignment to ask us to program one of these. Well, it's an actual problem that they had. So we're going to, that they had at Water Commission. So we're going to post that as a problem for you to write the program and simulate it and run it. So while I'm here, housekeeping matters. So we say that there's so much people there. There's only 8 people here. Where exactly are we located? Maybe I should wait until there are more people, because we need to be able to. Yes, it's good to be talking about all of these things, but we need to be able to say when is it that we're going to go up UTech, which days we're going to go up UTech, and actually. So where are we located? Can us have an indication?
Well, sir.
I don't need the address. I just need so that we can do some logistics.
I'm in St. Anne.
I'm at Kingston.
All right, so 1 St. Anne, 1 Kingston. Where else? You're still there for, so you know, better come back. Yeah, them all let you. Them all let you back out. All right, because basically, so in the next 2 weeks, go on to our practical session. Now, my gentleman of foreign, when you come back, you just have to catch up with the program at that point in time. Either that, or you buy one of the $25 PLC and go and learn how to program it. Yeah, we can send you the link for the cheap PLC though. All right. So in the next 2 weeks, we want you to come to UTech, and then we have a practical session. The group is small, so everybody can just come one time. Would Thursday or Friday be more feasible?
If it's gonna be on a Friday, would it be which approximately what time? What time of Friday?
Well, I have a class 12 to 2 on Friday, but then that wouldn't be an issue because I can. Well, I'm saying it can be any time on Friday. Thursday now is from 3 up. Friday can be from 10 up.
Sorry, what are the Friday lab?
Yeah.
So the Tuesday class out.
No, sorry. So you want to do the class Tuesday 11 o'clock as scheduled?
I mean, I think most of us free at that time. Thing is, Friday some people have class and Thursday others have class. So
All right. So in the next 2 weeks, Tuesday at 11. All right. So Tuesday at 11. In not next week, the other week. Get the access to come in and
all right, sir.
all right. So that's the first thing. Next thing, how the assignment, we're going to give you one practical test. All we have to do is write a program, wire up the thing and connect it and make it run.
Yes, sir.
Mhm.
I came in late, so I'm not sure if you had indicated whether or not you had sent the book in the group or.
No, I've been negligent. I haven't sent the book in the group.
Okay, so it's next week.
When I said I would send the book in the group, that's when my phone come out. And instead of trying to buy a phone, I was trying to get a battery without. So I ended up buying a phone. So I would.
Facebook, sir.
Sir,
So I'll send the book in the group.
approximately how long would the practical session be?
Suited. So 11 to 2.
11 to 2. Wait, on which days? Tuesday?
Tuesday.
All right.
Yes, sir. For the assignments, you're saying you're going to drop the first one next week?
Yeah. So one multiple choice, one practical test, and 2 programming assignments.
Okay.
So the first one, well, not next week. By tomorrow, I will send it in the WhatsApp group. So it's 2 programming assignments we asking you to do. So and the waiting, we go again, 10, 20, 30, 40. So the multiple choice test that we're going to give you is about 30 questions you're going to get. We're giving you 2 tests and we're taking the higher of the 2. So it's 30 questions and that were 10%. The practical test, like I said, we're going to ask you to write a program Now we're going to ask you to wire up something. So that again is 20%, and the two programs are assigned with 1 word 30, 1 word 40. So the one that you get in next week is 30%. Or one that you get in later is 30%. Okay?
Yes, sir. Noted.
All right. So the next 2 weeks, on a Tuesday, and for at the end of the 4th session, that is when you're going to ask you to do the practical test. All right, so it's 4 Tuesdays in a row. And at the end of the 4th one, we're going to ask you to do the practical test. Not that because of the fluidity of the situation, not that if you don't come on that 4th Tuesday, then that is it. So is at the end of the 4th Tuesday, you're going to get at the end of that time, you're going to get the test. Whenever it is that you come in, you do the test. And we sort it out. So you will schedule when you're going to come in and do the test, whether it be the other Tuesday or however it work out. So we are going to be fluid on the practical test. The multiple choice is going to be online. So we're going to tell you when it is up and leave it up, and you do the multiple choice test. One attempt. If you're not happy with that first attempt, you do the next one. And whichever one is higher of the two, we work with that.
What assignment next week? When will it be due?
Normally I call it them at the end of the semester. By the end of the semester. Some people do it long before, but I'm not putting any massive deadline on it to say, I need it done in 3 weeks. I need everything by the end of the semester.
Okay, noted, yeah.
Please
Okay.
Please note.
You can go ahead.
You can ask for assistance with the project and everything like that, but you cannot need somebody else's one.
Okay, so question, sir. Based on my experience when it comes on to coding projects, when we get the project next week, will we have would we be able to do a certain amount of the project based on the knowledge that we have now, or would we still need to wait until we finish more weeks
No.
before we can actually get much progress done on the project?
No, when you get the project, the one that I'm going to give you now is based on everything that you have learned up to now.
Okay, because I have had some projects where like they include some of the stuff that we have learned, but you have to like hold off on a lot of it because you have a lot more stuff to cover in the following weeks. So I just wanted to make sure that won't be an issue.
No, that will not be an issue because the project that you're going to get will require that you use the knowledge that you have already. Nothing else. So that's why, for example, we say we're not giving you the practical test until you have done the 4 sessions. So when you have learned what is required, then you do whatever it is. So when you have learned what is required to do whatever, then we give you the assignment. And that's why I haven't talked about the multiple choice test, because there are some things that we have left to talk about.
So for the for the practical test, you mentioned so if for whatever reason we're not able to attend for a particular Tuesday, we should let you know when when we're actually going to be coming down for it then.
Yeah, because remember now, the lab has to be open and the lab tech has to be there. I have to be there.
So I assume we'll email you then to let you know.
Email me, put it in the group, call me, whatever. So this song say you can reach me by whatever fax machine.
All right, noted.
All right.
Excuse me, sir, just a moment. So, is that so by you and the lab tech would be available for all the shows days?
Yeah.
What? Oh, okay.
Will be available for all the Tuesdays. Okay.
Yes, sir, noted.
All right. So what I'm going to do, I'm going to stop here for this evening. I'm going to so maybe later this evening I'll put the assignment in the group and you can start working on it. Like I said, in this fluid time, I'm not putting any massive deadline on anything. So I need it by the end of the term. Bear in mind that you get the 40% assignment. I also need that by the end of the term. So it don't make sense to sit down and wait until the end of the term to run up and down and give me all the assignments. All right. So so I'm going to go and put the book in the group and put the assignment in the group presently. All right. And like I said, next 2 weeks, not next week, the other week, we're coming in for practical. Except my version would have for it. But you still have to go come in a couple of weeks and sort out yourself and then do the test. So we're good with that?
Yes, sir.
All right. So we'll stop in there for today. And we continue next Thursday.
All right, sir. Take care.
Okay.